Configuring router via HTTP protocol. Outline. An overview of HTTP, sending and receiving process, www service and HTTP. Configuring HTTP built-in service in a router using Cisco Configuration Professional CCP. An overview of HTTP. HTTP stands for Hypertext Transfer Protocol. The Hypertext Transfer Protocol, HTTP, one of the protocols in the TCP/IP suite, was originally developed to publish and retrieve HTML page and is now used for distributed collaborative information systems. HTTP is used across the World Wide Web for data transfer and is one of the most used application protocols. HTTP specifies a request and response protocol. When a client, typically a web browser, sends a request message to a server, the HTTP protocol defines the message types the client uses to request the web page and also the message types the server uses to respond. The three common message types are GET and POST and PUT. GET is a client request for data. A web browser sends the GET message to request pages from a web server. Once the server receives the GET request, it responds with a status line such as HTTP 1.1 200 it means OK, and a message of its own, the body of which may be requested file, an error message or some other information. POST and PUT are used to send messages that upload data to the web server. For example, when the user enters data into a form embedded in a web page, POST includes the data in the message sent to the server. PUT uploads resources or content to the web server. Although it is remarkably flexible, but HTTP is not a secure protocol. The POST messages upload information to the server in plain text that can be intercepted and read. Similarly, the server responses, typically HTML pages, are also unencrypted. For secure communication across the internet, the secure HTTPS protocol is used for accessing or posting web server information. HTTPS can use authentication and encryption to secure data as it travels between the client and server. HTTPS specifies additional rules for passing data between the application layer and the transport layer. The sending and receiving process. When sending messages on a network, the protocol stack on a host operates from top to bottom. In the web server example, we can use the TCP/IP model to illustrate the process of sending an HTML web page to a client. The application layer protocol, HTTP, begins the process by delivering the HTML formatted web page data to the transport layer. There, the application data is broken into TCP segments. Each TCP segment is given a label called a header, containing information about which process running on the destination computer should receive the message. It also contains the information to enable the destination process to reassemble the data back to its original format. The transport layer encapsulates the web page HTML data within segments and sends it to the internet layer, where the IP protocol is implemented. Here, the entire TCP segment is encapsulated within an IP packet, which adds another label called the IP header. The IP header contains source and destination host IP addresses, as well as information necessary to deliver the packet to its corresponding destination process. Next, the IP packet is sent to the network access layer, Ethernet protocol, where it is encapsulated within a frame, header, and trailer. Each frame header contains a source and destination physical address. The physical address uniquely identifies the device on the local network. The trailer contains error-checking information. Finally, the bits are encoded onto the Ethernet media by the server network interface card. This process is reversed at the receiving host. The data is decapsulated as it moves up the stack toward the end user application. www surface and HTTP. When a web address or URL is typed into a web browser, the web browser establishes a connection to the web surface running on the server using the HTTP protocol. URLs, or Uniform Resource Locator, and URIs, Uniform Resource Identifier, are the names most people associate with web addresses. The URL http://www.cisco.com/index.html is an example of a URL that refers to a specific resource. Web browsers are the client applications our computer uses to connect to the World Wide Web and access resources stored on a web server. In order to access the content, web clients make connections to the server and request the desired resources. The server replies with the resources, and upon recipient, the browser interprets the data and presents it to the user. Browsers can interpret and present many data types, such as plain text or hypertext markup language. Other types of data, however, may require another service or program, typically referred to as plugins or add-ons. We can examine how a web page is opened in a browser. For this example, we will use the URL http://www.cisco.com/web-server.html. First, the browser interprets the three parts of the URL. Number 1, HTTP, which is the protocol or schema. Number 2, www.cisco.com, the server name. And the part 3, web-server.html, the specific file name requested. The browser then checks with a name server to convert www.cisco.com into a numeric address, which it uses to connect to the server. Using the HTTP protocol requirements, the browser sends a GET request to the server, asks for the file web-server.html. The server in turn sends the HTML code for this web page to the browser. Finally, the browser deciphers the HTML code and formats the page for the browser window. Configuring HTTP built-in surface in a router. Open the GNS3 program. I'll call the project using HTTP. Drag and drop 7200 router with the cloud. Configure the cloud by attaching loopback adapter. Select the loopback adapter and click on Add. Then OK. Link them. Click on Show Interface Tables. Turn on the router. Configure the router using console connection. Navigate to Configuration mode. Configuring interface Fast Ethernet 0/0. Configure the IP address for loopback adapter. Testing the connectivity using ping. Succeed. Testing the connection from the host to the router. Succeed. Showing the current configuration for HTTP surface. HTTP and HTTPS services are not enabled. To enable HTTP service, type IP HTTP server. Navigate to your browser and type the IP address for that router in the address bar. Connection to the built-in web-based interface for that router was successful. There are levels of privileges to configure the router starting from 0 to 15. 15 is the root or an administrator. Currently, I'm inside Enable Exec mode with root 15 privileges. You can type all the commands for Enable Exec mode in this text box. I'll show the configuration for the interfaces by typing show IP interface brief. To configure and manage the router, navigate to Config mode. I'll configure the interface Fast Ethernet 0/1. An IP address assigned successfully. Now, turn on the interface. To show the configuration for the interfaces in config mode, type do show IP interface brief. Fast Ethernet 0/0 configured correctly, and the link is up. The default port for HTTP is 80, but in case of this port was used by another service, you have to change it to another port number. To change the port for HTTP service, type IP HTTP port and the port you want to associate it. If you reload the web page, you will be no more able to access that router. To access that router, type colon with the port number. Even when I navigate to a different location, this port sticks with the IP address of that router. At this point, anyone can access this router with the IP address. To prevent this, add authentication to the HTTP and HTTPS services by typing IP HTTP authentication local. Local signify authenticate the user using the record stored in the router's database. Add user record in the database by typing username and the name for this user. Privilege 15 imply the root with a secret password. It's an encrypted password for this user. For simplicity, make the username with the password admin. Now, if I reload the web page, I'll be asked to identify myself. It's not allowed to access the router anymore, only with the right privileges. The username and password were admin. Now, I'm authorized to log into this web-based configuration interface. Till now, the connection is not secure. To secure this connection, enable the HTTPS service. To enable HTTPS, type IP HTTP secure-server. If I reload the web page, nothing changed, and that's because both HTTP and HTTPS enabled. Try to connect using HTTPS. SSL connection error, and that's because the port number for HTTPS 443 and 8080 was customized for HTTP service. Delete the port number 8080, then reload the web page. This error is normal because my certification for HTTPS is not valid. Right now, my goal is to use HTTPS. Click on Advanced. Click on Proceed to that error. Now, I'm asking to identify myself. The connection to the router established successfully using secure HTTP. But there is something you have to take care about, and that's both HTTP and HTTPS services are enabled. To disable HTTP service, type no IP HTTP server. HTTP service is not accessed for that router anymore. Only by HTTPS service. That was the basic configuration for HTTP and HTTPS built-in services in the router. I'll use this configuration to connect to this router using Cisco Configuration Professional CCP. Cisco Configuration Professional CCP. Cisco Configuration Professional. Its tools or program enhance productivity and help network security administrators to deploy routers with increased confidence and ease. Cisco Configuration Professional is offered in two versions: Cisco Configuration Professional and Cisco Configuration Professional Express. Cisco Configuration Professional offers Smart Wizard and advanced configuration support for LAN and WAN interfaces, network address translation NAT, stateful and application firewall policy, IPS, IP secure, and SSL, VPN, and Cisco network admission control policy features. IT managers can easily organize and manage multiple routers at a single site. Cisco Configuration Professional offers monitoring of router status, troubleshooting of WAN and VPN connectivity issues. Cisco Configuration Professional Express is a GUI-based embedded device management tool for Cisco Integrated Service Routers (ISR). It is available on the flash of the router and used for bootstrapping and basic configurations. In this session, I'll be using Cisco Configuration Professional because its ease of use and built-in application intelligence. With Cisco Configuration Professional, you can configure and monitor your Cisco routers without using the Cisco IOS software (CLI) command line interface. If you're not an expert with Cisco IOS software, the Cisco Configuration Professional GUI can help you in your day-to-day operations. The application provides easy-to-use smart wizards, assist you through comprehensive online and video help. Run the setup file for the CCP as an administrator. Click on Next. Choose I accept and click on Next. Next, click on Install. Click on Next. My operating system passed the minimum requirements. Also make sure that if the firewall blocks CCP, then you have to enable it. Click on Next. Click on Finish. Make sure to run CCP always as an administrator. Open CCP. Close this window. This is old community group of network devices. I'll delete it. I'll create new community. I'll call it Koya Routers. Adding the IP address for that router you want to connect to with the credentials. Since I disabled HTTP service, only HTTPS working, so I'll check this checkbox to use HTTPS protocol. Click on OK. Click on Discover. Click on Yes. Wait for a while. This router discovered with warnings. Click on Discovery Details. This warning is not big deal. The most important that our router was discovered. Now, with CCP I can configure and monitor that router. I will change the IP address for interface fast Ethernet 0/0. Click on Configure. Expand Interface Management. Navigate to Interface and Connections. Click on Edit Interface/Connection. To edit interface fast Ethernet 0/0, double click on interface fast Ethernet 0 or select the interface and click on Edit. I'll change the last octet for this IP. Click on OK. Click on Deliver. Configuration delivered to device. Check the interface configuration using console connection. With CCP you can monitor the router. CPU and memory usage with interface status and many other details. See you in the next lecture.